So we are going to take the point A. We are going to multiply it by the transformation, and we are going to get the image A prime. So we have 2 minus 3 and 2 minus 1, 0, 2, 0. So we need to know which one comes first, whether it is the transformation or the point. So the only way for us to decide that is if we write down the order of the matrix. So the order is the number of rows by the number of columns. So rows, we have 2 rows by 1 column. Here we have 2 rows by 2 columns. So therefore, these two numbers must be the same. So we need to put the transformation first and then the point. So this is a 2 by 2. This is a 2 by 1. My resultant matrix is going to be a 2 by 1. So the translation comes first and then the image and then the point to get the image. So we multiply row 1 by column 1. So row 1 by column 1. We multiply corresponding elements. First element with first element. So 2 multiplied by 2 will give me 4. Then second element with second element. -1 multiplied by -3 will give me +3. So first element with the first element. This is -2. So this will give me -4. And this is +3. So this will also give me -3. All right, so we just want to make that correction is -2, 3. Yes, right? So let me start over. We have the translation T, which is 2 minus 1, 2, 0. We are going to multiply it by the coordinates of A, -2, 3, and that is going to give me the coordinates of the image. We multiply row 1 by column 1. We multiply row 1 by column 1. So first element, 2 by -2 is -4. Then we multiply second element, -1 by 3, which will give us -3. You have to do the same thing for row 2. So multiply row 2 by column 1 for me. Go ahead. Take it down and you have to multiply row 2 by column 1 to get the second elements. First element, second element. Multiply it and see what you get. So the first point I have here is -7. All right, -2 by 2 is -4, and any number multiplied by 0 is 0. So I have -4, -7. Do you all have that?
Yes, yes.
So when we are working out the transformation that takes a point A and produces an image, the transformation matrix must come first. Because when we are multiplying matrices, the number of columns of the first must be equal to the number of rows of the second. And my resultant matrix is a 2 by 1. And here we can see this has 2 rows and 1 column. So we want to be mindful of that. Determine the transformation that maps A prime back to A. So watch this. A is mapped by some transformation to A prime. If we want to find what maps A prime to A, we have to find the inverse. We want to find the inverse of the transformation, because just like a function, it takes an input and generates an output, right? The inverse does the same thing. The inverse takes the output and goes back to the input. So what they are asking you to find here is to find T inverse, all right? So T is equal to 2 minus 1, 2, 0. And we want to find the determinant of T. So you're finding the determinant by crossing opposite ends of the diagonal. So you multiply 2 by 0, take away -1 by 2. And T inverse is equal to 1 over the determinant. And if the matrix is A, B, C, D, we switch positions of D and A and take the negative of B and the negative of C. So work it out. Find the determinant and switch places of D and A and take the negative of B and the negative of C. So the transformation that maps the object back to the image is indeed the inverse. All right, so any number multiplied by 0 is 0. Minus 2, we will get 2. Did you all get 2 for the determinant? Did you all get 2 for the determinant?
Okay.
So T inverse is 1 over 2. And we switch positions of D and A. So here we get 0 and 2. And we take the negative of B and C. So this will be 1 and negative 2. Did you all get that?
Miss.
Yes.
Miss, in the first part, I think you make a mistake, you know, miss.
Where?
Miss, you can scroll up.
All right.
By 2 by negative, well, negative 1 by negative 2.
Negative 1 by negative 2 just now, Jordan. So 2 by 0. So we multiply 2 by 0. We will get 0, and negative 1 by 2 will give us negative 2. So we have 0 minus minus 2. This is 2. That part is correct, okay?
Miss, not that part, miss, in the bracket.
In the bracket, all right, when I write it, 2 minus 1, 2 minus 1, 2, 0. So we switch in this bracket you're talking about?
No, miss, in that same line, we are just not explaining, but underneath.
This one here?
No, miss, you have to go up.
I have to go up or down?
Miss, you see in row 1, right, miss?
Mm-hmm.
When you multiply negative 2, well, negative 1 by negative 2, you put negative 3.
Oh, I put negative 3. Which part is that, Jordan? Oh, here. This part here. This, when I multiply negative 1, when I multiply negative 1 by 3, I will get negative 3 here. That is what you're talking about?
Yeah, miss.
So we multiply in the first row by the first column. So 2 by negative 2 will give me negative 4. And negative 1 by 3 will give me negative 3. So negative 3 minus negative 4 will give negative 7. Is that what you're concerned with?
Yeah, miss.
All right, so that part is correct. You could check it back, right? The answer here, did you all get that? The half, 0, 1, negative 1, 2, and negative 2, negative 2. Did anybody get this? All right, let me write a note here because you all probably can't remember. If A is the matrix A, B, C, D, the determinant of A is AD, AD minus BC, and A inverse is 1 over A, and we switch positions of D and A and take the negative of B and C. So you can take down that, the inverse of A. All right, take down that, please. When you finish, when you finish write this, see if you will get this answer for me, please. All right, are you all finished writing?
Yes, miss. Yes, miss.
Another transformation, P is defined as a matrix P 0, 1, 1 minus 2. Find the 2 by 2 matrix that represent the combined transformation. So T followed by P means that we have PT. PT. T is done first. So we want the multiplication, the matrix multiplication, PT. So we have 0, 1, 1 minus 2. We are going to multiply this with 2 minus 1, 2, 0. So this is a 2 by 2, and this is a 2 by 2 matrix. So the resultant matrix will be a 2 by 2. So we multiply the first row by the first column. So row 1 by column 1. We multiply corresponding elements. So it will help if we label this row 1, row 2, column 1, column 2. The next one, we multiply row 1 by column 2. So that is the second set of elements. So we multiply row 2 by column 1 and then row 2 by column 2. So we multiply row 1 by column 1. We multiply first element by first element. 0 by 2 will give me 0. And 1 by 2 will give me 2. So my first element is 2. Then I multiply row 1 by column 2. So 0 by minus 1 is 0. And 1 by 0 is also 0. So take it down and you multiply row 2 now. Row 2 by column 1 first and then column 2 second. Write it down and take it down. All right, let's see what you all have. So we multiply negative, we multiply positive 1 by 2. So 1 by 2 is 2. And we multiply negative 2 by 2. So we have 2 minus 4. Here we will get minus 2. Did you all get that?
Yes, miss.
Then we multiply row 2 with column 2. 1 by negative 1. This will give me negative 1. And negative 2 by 0 is 0. So the matrix that we are looking for is 2, 0, negative 2, negative 1. Yes?
Excuse me, miss.
Yes?
I have a question.
Mhm.
For row 1 and column 1, and 0 by 2 is 0, and then 1 by 2 is 2.
Which part?
Oh, that one. By row 1 and column 2.
Row
Okay.
1 and column 2, go ahead.
Yeah, how you get 0?
Because 0 by negative 1 is 0 and 1 by 0 is 0.
Oh, okay, thanks.
This one you're talking about, right?
Yeah, thanks, miss.
All right, let's go through it. For those of you all who don't understand it, let me go through it again.
Oh my God, Brittany.
Come, it will help us, right? Let me do it. You asking somebody must you want to know too. So we multiply row by column. So 0 by 2 is 0. 1 by 2 is 2. So the first number that I am going to get is 2. Then we multiply it by the next row. So 0 by negative 1 is 0 and 1 by 0 is 0. So that is my second element. We go into this one now. 1 by 2, 2. 2 by minus 2 minus 4. This will give me negative 2. 1 by negative 1, negative 1, negative 2 by 0, 0. Right? Find the image of the point 1, 4 under this combined transformation. So we're working out 2, 0, minus 2, minus 1, 1, 4. Go ahead. Multiply it. Multiply this. Row 1, column 1. That is my first element. And then row 2, column 2. Go ahead and multiply it.
Finish, Miss.
Right. So first element, 2 is being multiplied by 1. That will give me 2. Second element is being multiplied with second element. 0 is being multiplied by 4. That will give me 0. Did you all get that?
Yes, Miss.
Yes.
Right? First element, negative 2 is being multiplied by 1. So this is negative 2. Then second element, negative 1 is being multiplied by 4, which will give me negative 4. So this is 2, negative 6. Did you all get that?
Yes, Miss.
Right. Before we do the matrix. Yes, Christian. Before we do the matrices. Very good. I am most proud. All right. Now, it has some transformational matrices that you must know, right? I will send it for you in a short while. But we need to work out this question. This question takes R and it creates R prime. So the first thing I want you to do in your book is to write down the coordinates for me of R and R prime. Write down the coordinates for me of R and R prime.
Finish, Miss.
All right, Brittany, give me the coordinates of R.
2 and minus 5.
2 and minus 5. All right, someone else, you give me the coordinates of R prime?
5 and 2.
Yes, 5 and 2. Now watch this. According to this and this, the numbers are similar, but the X and Y is reversed and one is positive and one is negative. So there is some relationship between R and R prime. But just like in the next question that we did, the question that we did previously, we took a transformation and we applied it to a point and we got the image. So here they give you the answer and they want you to work the transformation. So remember, I told you the transformation must come first because that is the 2 by 2 matrix. So watch this. So the matrix, the transformation M multiplied by R will give us R prime. So what is R? R is this, 0P-Q0. 0P-Q0. What is R? You now give me the coordinates of R. 2 minus 5, and this will give me 5, 2. So I want you to multiply this by this for me and equate the coefficients. So multiply row 1 by column 1, multiply row 2 by column 2. Go ahead. So we're supposed to get 0 by 2, which is 0, and P by minus 5, which is minus 5P. Do you have that?
Yes, miss.
Q by 2, 2Q, and 0 by 5, 0. So you see, my first line has P and my second line has Q. So now minus 5P is 5, find for me P, and 2Q is 2, find Q. Go ahead. So P is minus 1 and Q is positive 1. Did you all get it?
Yeah, miss.
So the matrix that we are looking for is 0, minus 1, 1, 0. And that wasn't too bad, right? So the first thing we're going to describe fully the transformation. So let us go back. So the first thing we're going to write, M is the transformation 0, minus 1, 1, 0. Now, we are going from R to R prime. Is that clockwise or anti-clockwise?
Anti-clockwise.
Anti-clockwise, because the clock turns like that. The clock goes like that. So this goes in this direction. So that is the second thing. Remember, it's 3 marks. So we got to write something for the 3 marks. So it is an anti-clockwise rotation about the origin, and the angle of rotation is 90 degrees. So anti-clockwise rotation about the origin, and it is 90 degrees. So for 3 marks, we would have scored our 3 marks. So they are bringing transformational matrices. So expect to get something similar. Remember, when you are merging a point and the transformation, because the transformation is a 2 by 2 matrix that comes first, right? Because the number of columns and the number of rows must match up. So let me show you what I mean in case you don't know. For a 2 by 2 matrix, and if we have a 2 by 1, we must put it in that order, because these two numbers must be the same. So this is the number of columns of the first must be equal to the number of rows. This must be the same. And when we multiply the matrix, we will get a 2 by 1. If we put it in the reverse or the opposite order, if these numbers do not match, the matrix cannot be multiplied. All right. Another thing they say they are going to bring is vectors. They are going to bring the parallelogram law of vectors and the triangular law of vectors. So we're going to look at that. So this is a parallelogram. So this is why I chose this question. And PQRS is a parallelogram in which PQ is U. So P to Q going in this direction is U. So also going in this direction is SR. So SR can also be written as U. Going in this direction, PS is V. So going in the same direction, QR is also V. So I'm going to stop and I'm going to give you a minute to draw the diagram in your book. Let me know when you have it, okay? Are we ready?
Yes, miss.
All right. Circle for me Q. Circle for me S. We want a vector QS. Q is my starting point. S is my end. So the first vector I am going to write is Q. And the final vector is S. Whichever letter I am going to write must be the same. So I can go from Q to P. Notice I am going in the opposite direction. So QP is the opposite of PQ. So if this is U, this will be negative U. When you go in the opposite direction, the vector must change, right? So this is negative U. And I can go from Q to P and Q to S. Do you see that that forms a triangle?
Yes, miss.
So the answer is minus U plus V. So take that down. This is the triangle law of vectors.
Finish, miss.
Right. We want to go from Q to M, but the information that we have is QM to MS is 1 to 2. So therefore, if I have a line, this is Q, this is M, and this is S, and it is split into 1 to 2, the line is split in how many parts? What is the total number of parts?
3 minutes?
Very good. So this line is split into 3 parts. So therefore, QM is 1/3 and QMS is 2/3. So we already have QS. So QM is 1/3 of QS. And we work out QS already. So this is 1/3 of minus U plus V. Let me know when you all are finished. The next part is to show MR is something. So they give you the answer. Now you have to show it. So let me erase here. So I am going from M to R. So M is my start, R is my end. We already have this vector here as U. So I am going to write MR. The first letter tells me where to start. So I am starting at point M. The second letter tells me where to end. I am ending at vector R. So I could go from M to S and S to R. Do you all see that?
Yes, Miss.
No, we already established MS is 2/3 QS, and we already have the vector SR to be U. So it is only a matter of combining it now. So MR is 2/3 QS plus, no, just write it, MS plus SR. So MS is 2/3 QS, which is 2/3 of minus U plus V. We just work out that, because if this is 1/3, this could be 2/3. That was self-explanatory. SR is a vector U because it's going in the same direction. There's no need to change anything. Plus U. So we multiply each term by 2/3. So minus 2/3 U plus 2/3 V. So simplify that and see if you get this answer. One U minus 2/3 U. How much is 1 minus 2/3?
Wanted, Miss.
So 1/3 U plus 2/3 V, and 1/3 is common, so I can take that out. I will get 1/3 plus 1/3 open bracket U plus 2V. So I have proven what they asked me to show. They asked me to show that R, M, and T are collinear. So M is here, this is Q, this is R, this is T, which is a half of PR. So we already have MR. MR is 1/3 U plus 2V. So to show collinearity, we need to show one vector is a scalar multiple of the other, and they share a common point. So we can find the vector TR. So the vector TR will take us from T to Q and Q to R. So we have the vector PQ, which is U. That is what we have from the beginning here. And we have this vector here, QR, which is V. So we have that. So this is V. So TR is TQ plus TR. TQ plus QR. Now TQ is a half because it is the midpoint. So this is a half U. So a half U plus V. So if I take out a half from my equation, if I take out a half, I will get U plus, and a half multiplied by what number will give me 1? What number do I put in the bracket here? A half of what number is 1? A half of what number is 1? A half of 3, a half of 6, a half of 4, a half of what number? Nobody knows?
2.
2. So a half of 2V. Do you notice that this bracket is the same as this bracket here? Do you see that this bracket is the same here?
Yes, miss.
Yeah, miss.
Here's what we write in. We write in that, and we must write this, MR is a scalar multiple of TR, and R is the common point. So T, M, and R are collinear. So for collinearity, you must show that one is a scalar multiple of the other, and you must state that they share a common point. That is how you show collinearity. Any questions?
No, miss.
All right, so all right, so we are going to do the vectors and matrices question. This is taken from the most recent past paper. This is taken from the 2021 paper. And the vectors and matrices is a good question where we can attempt to score maximum marks. CXC hardly ever deviates from what they ask. And once we have a fair idea of how to answer the question, it should give us an opportunity to get some actual marks in this question. All right. Calculate the product of those two matrices. Before we attempt to work out the product, we need to ensure these two matrices are what we call conformable for multiplication. Conformable means that the two matrices can be multiplied. So here we have a 2 by 2, and here we have, this is row by column, this is row by column. We have 2 rows and 3 columns. As long as these two numbers are the same, the matrices can be multiplied. So we will form a 2 by 3. What this means, and they ask for you to state why the matrices are conformable. Well, the number of columns of the first matrix is equal to the number of rows of the second matrix. So once we do that, we know we find in a 2 by 3. That is our end result. So we are multiplying first row by first column. We can do a bracket and we know it's a 2 by 3. So the first element, 5 by 2. 5 multiplied by 2 will give me 10 plus 5 by 0, which is 0. So that is first row, first column. So the first row by the first column, 5 by 2, and then 5 by 0, right? 5 by 2 and then 4 by 0. So this is row 1 by column 1, column 2, column 3. So this is row 1, column 1. So the next one, the next element, row 1 by column 2. So we multiply 5 by 1, 5 by 1 now, plus 4 by 3. So we have finished with row 1, column 2. So we go into row 1, column 3 now. So 5 by, so the first element by the first element. The first element here by the first element, the second element by the second element. So 5 by negative 4 plus 4 by 4. Now, I'm going to stop there and I want you to multiply row 2 by column 1, row 2 by column 2, and row 2 by column 3. So you try it, and we multiply corresponding elements. First element with first element. Second element with second element. So try it. All right, are you all finished? Nicole and Bridget, are you all finished?
Yeah, miss.
All right, let's see what you have. So now we're doing the second row, first column. So first element, second element. So minus 3 by 2 plus minus 2 by 0. Right? Then we have minus 3 by 1 and minus 2 by 0. Then we have minus 3 by minus 4 and minus 2 by 6. So let me try and simplify. 10 plus 0 is 10. 5 by 1 is 5 plus 12. So far we have 10, 17. This is minus 20 plus 5 by 4 plus 4 by 6. This was 4 by 6. So this is 4. Then minus 6 plus 0, minus 6, minus 3 by minus 3. So this is minus 9. And then 12 minus 12, 0. Did you all get that? Or anything close to that?
Miss, I got something to say, but it's okay if I take it on?
Yes, yes, go ahead. Nicole, what about you? What do you have?
Miss, I wrote for the second row, minus 6, I put 0.
Oh, all right.
Yes.
So you make a note of that change, right?
Finish, Miss.
Mhm. All right, you finished? Bridget, you still writing?
No, miss, I finished.
Okay, let's go. Find the inverse. So to find the inverse, we need to find the determinant. So the determinant, if A is A, B, C, D, then the determinant of A is A by D minus B by C. So I want you to do it. 5, 4, negative 3, negative 2. So the determinant of A across opposite ends of the diagonal. Are you all finished?
Yeah, miss.
So 5 multiplied by -2 is -10. Take away 4 multiplied by -3. So this will give us -12, which is -10 plus 12, which is 2. So the determinant is 2. The inverse now is 1 over the determinant, and you switch the places of D and A, and you take the negative of B and C. So using this, find A inverse. Switch the places of A and B and change the sign of B and C. So it's 1 over 2. You fill in what's supposed to be there.
Finish, miss.
All right, so you're supposed to have -2, 5, -4, 3. Do you have that?
Yeah, miss.
Yeah, miss.
All right. This one, let me erase the answer. Now, we just need to understand the vectors and matrices, because CXC hardly ever deviates from this question. So this one has been the same since I don't know how long. So let's see what they ask in the question. The diagram below shows a triangle, AOB. So we can see that triangle. OA is R, so we know that. And OB is S. So we see those, right? In addition, E is the midpoint of CD, right? And OC is 3/4 OA. So if OC is 3/4 OA, therefore this part here is a quarter, because 3/4 plus a quarter will give us a half. You all understand that?
Yeah.
Yeah.
AD is 2/3. So how much would BD be? If here is 2/3, how much again to make a whole? 2/3 plus how much? 1/3. So that is some information we can put in our diagram. They are asking us for CD. So they want the vector CD. So we look at the route. We're going from C to D. But we cannot go, so we have to use the triangle law of vectors. So the other two vectors that will take us from point C to point D is if we travel through A. So it's like you are going from point C to point D, but you cannot walk straight across. You have to find an alternate route. So therefore, you will go from C to A and then from A to D. Do you all see that?
Yes, miss.
So CA plus AD. And when we write in vectors, this C is always my start, D is always my end, and whatever I put in the middle here must be the same. That is the common point. Are you all with me so far?
Yeah, miss.
So, let's know it. Right. So, a quarter of R, because the whole vector OA is R, so a quarter of R plus AD. AD is 2/3 AB. So we need to find, so it's 2/3 of AB. So we need to find the vector AB because that wasn't given. So watch this. We're going from point A to point B. So we will travel to O and then we will travel to B. But if we go from A to O, the vector must change the sign. It is like you are walking forward, now you're walking backward. So this would be 2/3 minus R plus S. So a quarter R minus 2/3 R plus 2/3 S. So work out for me a quarter minus 2/3. How much is that? A quarter minus 2/3. How much is a quarter minus 2/3? Use the calculator.
Miss 512. Minus 5.
Minus 5/12. R plus 2/3 S. Do you all understand how I got that?
Yes, miss.
All right, so take it out. Let me know when you all are finished writing.
I finished, miss.
Bridget, you finished as well?
Miss, I know say I finished.
Oh, Nicole, you
Yeah,
finished?
miss.
All
Yes,
right.
miss.
Sorry. Now watch this. We need to understand what's going on here. They ask us to find OE. So let me draw a line from O to E. What is the shortest possible distance that I must travel to go from O to E? We know my start vector must be O, and we know my end vector must be E. So what point must I pass through? Nicole or Bridget, I want to go from this point to this point. How will I travel? From O to?
O to C to E, miss?
Yes, O to C, and then from C to E. So O to C and then C to E. The vector OC is 3/4 R. The vector CE is a half. Remember, E is the midpoint, so it is a half this vector that we found. because they said that E is the midpoint of CD. So plus a half minus 5/12 R plus 2/3 S. So work out for me, what is a half of minus 5/12? A half multiplied by negative 5/12.
Negative 5/24.
Yes. Negative 5/24 R. And how much is a half multiplied by 2/3?
1/3.
Yes, 1/3 S. Now simplify this for me. 3/4 take away 5/24. Three-quarter minus 5/24.
That's 13/24.
Just 13/20. 13/24 R plus 1/3 S. That is my answer. So you all feel free to take it out. Finish?
Yes, miss.
Right. Bridget, are you finished as well?
Miss, I just now answer.
Oh, Nicole, are you finished?
Yeah, miss.
All right. Let's go. What are the coordinates of R? What is the X value and what is the Y value of R? This is the point R here. What are the coordinates? What is the X value and what is the Y? X is how much?
-1.
Right? So if we have to write it as a row, as a column, -1, and what is Y? 4. So that wasn't too bad, right? -1, 4. That's the answer. They ask us to determine QR. They want the length of QR. So let's go back. We have to find the vector QR. So to go from, watch it, we're going from Q to R. Which vectors must we add to go from Q to R? Q to R will be what? I'm starting at Q and I want to end at R. So QR will be what two vectors?
5 to -1.
No, what are the vectors in terms of O? If I start at Q, where must I pass to reach R? Which route must I take to reach R? If you start walking at Q, Bridget, and you want to reach R, where must the triangle travel?
Q had to go down to 0
You have to go from Q to 0, Q to O.
to
So
R.
QR, you're going from QO and then from O to R. You see that? Watch. We're going from Q to O and then O to R. Want to see that? Do you all see that is the direction we must go to reach
Yes,
R?
miss. Yeah, miss.
Right. Now, what is the vector? What is this coordinate here for Q? What is the point? 5 what?
50.
No. 5 is the X. What is the Y?
Oh, 2.
So this would be negative, because if we go from O to Q, it's positive 5, 2. So this would be negative 5, 2. And the vector OR, we just worked out that was negative 1, 4. So work out this for me. Negative 5, negative 1, negative 2 plus 4. Work out that for me and tell me what you get.
Minus 6, 2.
Minus 6, 2. Bridget, you can confirm that? Bridget, you can confirm that answer?
Yes, miss. Miss, I hear ma?
No, I didn't hear you. So QR is the square root of the X value plus the Y value. And QR is the vector minus 6, 2. So work it out. Square the X, square the Y, and find the square root.
Yes, I get 10, and when I square it is 3.16.
All right. That's not it. You got, what did you get for X squared, Nicole?
36.
Yes. So 36 plus how much? 2 squared is?
4.
Right. So you get the square root of 40. And what's the answer you said?
10.
6.32. Check by that. The square root of 40.
I get 6.32.
Yeah, miss.
All right. So
Make
see
a
what you
mistake.
need to take down. Yeah. See what you need to take down there. And let's move to the other question. You ready?
Yeah, miss.
What's this, January 2020? I'll give it January 2021. Good afternoon, Nirmala. Okay, so this is the question. This is January 2021. They want a 2 by 2 matrix. Watch what it said. This is the matrix W. 3, 6, minus 2, 5. They want some matrix that will give this 0, 0, 0, 0. So what number, when we add to 3, we'll get 0. 3 minus what? 3 take away how much will give us 0?
Minus 3.
Minus 3. So fill in these values for me. 6 minus how much will give you 0? So fill in the spaces here for me. So what value would here be? The second value. 6 take away how much will give us 0? This will be minus 6. You have that? Right? This would be positive 2 because 2 minus 2 will give me 0. And this would be negative 5. You all get that?
Yeah, miss.
All right. We want a 2 by 2 matrix that will give us the identity. This is called the identity matrix. And a matrix W multiplied by 1 over W will give us 1. And this is the identity. So what they are asking you is to find the inverse, because this 1 over W is the inverse. So let's find the inverse. W is the matrix 3, 6 minus 2, 5. Let us find the determinant. So the determinant is when we cross opposite ends of the diagonal. And the inverse is 1 over the determinant. You're switching B and A, and you're taking negative of B and negative of C. So go ahead, work it out. All right, what do you have for the determinant? What did you all get for the determinant? 15 minus 2 by 6 will give us 15 minus 12, which is 27. Did you all get that? So this would be 1 over 27, 5, 3, negative 6, 2. Did you all put that?
Yeah, miss.
All right, let's continue. A right angle triangle has vertices 1, 1, 3, 1, 3, 4 when M is transformed by the matrix. So 0, 1, 1, 0, 1, 1, 3, 1, 3, 4. So this is a 2 by 2. This is a 2 by 3. The resultant matrix would be a 2 by 3. So row 1 by column 1. Work it out. Row 1 by column 1. Row 2, row 1 by column 2. Row 1 by column 3. Row 2, column 1. Row 2, column 2. Row 2, column 3. Try it. Multiply it and see what you get. For 2 marks. Tell me when you finish working it out, okay? All right, what do you all have? You finish?
Yeah, miss.
So the first thing is 0 by 1 plus 1 by 1. So I have 1. Do you all have that?
Yes, miss.
Then 0 by 3, which is 0, plus 1 by 1. This is 1,
Yeah, miss.
right? Then 0 by 3, which is 0, 1 by 4, which is 4. So my first row is 1, 1, 4. Did you all get that?
Yeah, miss.
Then we have 1 by 1 and 0 by 1. This is 1. Then 1 by 3 plus 0 by 1. This will give me 3. Plus 1 by 3, 0 by 3. So the vertices of x prime, 1, 1. The vertices of y prime, 1, 3. The vertices of z prime, 4, 3. Do you all see that?
Yeah, miss.
All right. So here's what, it's 4:51. Let's take a break until 5 o'clock. When we come back, we will continue with the paper 2 and we are going to the multiple choice. So we're taking a break for 10 minutes, right?
Okay.
All right. Are you all back?
Yes, miss.
Yeah, miss.
Let's see. We may go a little bit over 6 o'clock today, like about 6:15, but I just want to ensure that you understand how to do these questions as well as you can do the multiple choice, right? So bear with me a little bit today, as is our last class, okay?
Okay, miss.
The diagram below shows a triangle OPQ, which OP is 3U. So right away, this length here is U 2U plus U will give us 3U. You all see that?
Yeah, miss.
And OQ is V. So we have that. OQ is V. Right, we have that. Q is the midpoint of OR, right? And M is the midpoint of PQ. So we want to go from L to M. So if we are going from L to M, what two vectors must we add? What are the two vectors? To go from L to M, what two vectors we can add to go from L to M? We know the start vector must be L and we know the end vector must be M. So what two vectors?
L to P.
L to P. And here must be P to M. The vector in the middle here, this is the common vector and that must be the same. So we know LP is equal to U. We know that. We have to find PM now. We know M is the midpoint of PQ. So therefore, PM is a half the vector PQ. So we're going back because we don't know PQ. So to go from P to Q, we must go through point O, not so? Watch. We must go from P to O and then O to Q. You see that?
Yeah,
You all
miss.
see that? Right. So U plus a half PO plus OQ. So PO, we're going in the opposite direction. So PO is negative OP. And OP is 3U. So this is negative 3U. Negative 3U. And OQ is the vector V. So U plus minus 3 over 2U plus a half V. So if we have a whole and we take away, if we have a whole and we take away 3 over 2, we will get minus a half U plus a half V. Right? You all see that?
Yes, miss.
All right, so take it out.
Finish, Miss.
All right. The next one now, we want to go from P to R. So we go in P to R. So therefore, P to R would be my vector PQ plus QR. You all see that? P to Q plus Q to R. To go from P to R. You see that?
Yeah, miss.
But we don't know the vector PQ, but we know the vector O. So here how we could pass. We could go from P to O and then from O to R because we know those vectors. So PR is the vector PO plus OR. The vector PO is minus 3U and the vector OR is 2V. So take that out. This is part B. You have that?
Yeah, Miss.
Yes, miss.
All right. So the next part, prove that points are collinear. So to prove collinearity, we need to find the following vectors. So we have the vector LM, and we need to find the vector LR. To prove collinearity, you show two things. You show that they have a common point. In this case, the common point will be M, and one vector is a scalar multiple of the other. So we worked out this part already here, LM. LM was the first part. That was minus a half U plus a half V. So now to prove collinearity, we need to find the vector LR. So we're going back to our diagram. We want to find the vector LR. So to go from LR, I can go from L to O and then O to R. You see that?
Yeah, Miss.
You see those two vectors, right? So LR is the vector LO plus OR. LO is negative 2U. Why negative? Because we go in the opposite direction. And OR is 2V plus 2V. So that is LR. So take it down. Let me scroll down. You have that?
Yeah, miss.
Right. So this vector is minus 2u plus 2v. So you see both vectors have u and they have v, and this one is negative, this one is negative. You can see that?
Yes, miss.
So here what we have to write. LR is a scalar multiple of LM, and L is a common point. Therefore, L, M, and R are collinear. So to prove collinearity, one vector is a scalar multiple of the other, and they have a common point.
Finish.
All right, let's go to the next one. Did you finish?
Yeah, miss.
So in these types of questions, you just need to do about 1 or 2 because it's almost the same thing they ask over